So our dataset assignment was on the Framingham Heart Study. Some background, the Framingham Heart Study is one of the longest running health studies currently still going in the United States. It takes place in Framingham, Massachusetts, and it has followed original subjects since the 40s, their children and their grandchildren, looking for factors that affect cardiac health. The data also looks to see if smoking affects the cardiac health, systolic blood pressure, diastolic blood pressure, and cholesterol of a subject. Research question. So ours is there evidence of a difference in mean systolic blood pressure based on sex, the gender of the subjects? Introduction to the data. Variables. The variables in the data set are cholesterol, age, sex, systolic blood pressure, diastolic blood pressure, DPP, and number of cigarettes patients smoked per day on the day of their exam. We also added a variable titled smoker, which made it easy for us to gather information for non-smokers and smokers. For our research, we looked at systolic blood pressure for both male and females and compared them. SBP is measured in mmHg, millimeters of mercury. And data collection, the Framingham data was collected using electrocardiograms and blood tests, including cholesterol and glucose. Descriptions of the data. In the table below, you can see that females have a greater value for almost every descriptive statistic other than the minimum. The minimum is the same at both 90 for both male and female. But other than that, you can see that the females are greater, even in sample size, than males. And on the graphs on the right, you can see the male center is tighter and the female center is wider with a higher median, as you can see in the box plot. And the spread in both the box plot and histogram, you can see that the spread is much bigger in females, as it has a higher maximum than males and a lot more outliers as well. Shape, both the male and female shapes are skewed to the right. Descriptions of the data continued. In the QQ plots, it is observed that both females and males follow a normal distribution as they both move in a diagonal line. Both lines also deviate from the theoretical distribution at the end of the line. The female line is steeper and extends higher than the male line. This tells us again that the females have a wider spread and higher maximum values and outliers than the males do.
Confidence interval. What is a confidence interval? Pretty much what it is the probability that a statistic will fall between a set of values. And when trying to find that set of values, pretty much what that is the difference between the two sample means. So for Framingham, in our question, our sample means are the mean systolic blood pressure for males and the mean systolic blood pressure for females. And with those, what we're doing is just looking for the difference. So how we did that was we subtracted the female blood pressure from the male blood pressure and also input it in SAS, and that gave us our confidence interval of between 5.1727 and 10.9656. Pretty much what those numbers tell us is that we are 95% confident that the difference between mean systolic blood pressure in males and females lies between those two numbers. So a hypothesis test, pretty much what that is a claim about a characteristic of a sample or population. So before we even run our tests, we usually create a null hypothesis, which is where we state that there was no difference between male and female systolic blood pressures. And then after running SAS, we created an alternate hypothesis where we stated that we did find a difference between male and female systolic blood pressures. And pretty much how we came to that conclusion was looking at our p-value and our test statistic. So when interpreting the p-value is the probability of obtaining the observed results, assuming the null hypothesis is true. So if your p-value is high, that means that the probability of the null being true was high. So since our p-value was so low, we ended up rejecting our null hypothesis, which ended up showing that there was a difference between male and female systolic blood pressures.
For our limitations and assumptions, we have sampling bias, confounding variables, non-random assignment, measurement errors, and age differences. If the Framingham heart study does not include a representative sample of the population, the results may not generalize the general public. So that's for sampling bias. Then for confounding variables, there's more variables besides just male and female, like age, race, lifestyle, medications. All of those things can affect systolic blood pressure. The Framingham heart study was observational, meaning the participants are not randomly assigned to the groups, so that could have played a factor. Measurement errors. If the measure of systolic blood pressure was inconsistent or not precise, it could cause error in the study. Age differences. Age is a very important factor in systolic blood pressure, so that variable could be what's causing differences in these blood pressures. The assumptions we have are independence of samples, normality, equal variance, scale of measurement, and that there's no outliers. The improvements I would have made to the data collection is that I would have collected data from outside of Massachusetts to represent more of the general population. Conclusion. The point estimate, which is the best estimate we can make for the true value of the population parameter based on the data, was a negative 8.08. That shows us that on average, females have higher systolic blood pressure than males in the sample. We are 95% confident that the true difference in mean systolic blood pressure between males and females is in between 5.17 and 10.99. Since the entire confidence interval is positive, this shows us that females have higher systolic blood pressure than males. The p-value, which represents how likely the data is to occur under the assumption the null is correct, is less than 0.05 and is 0.0001. Therefore, we rejected the null hypothesis, which was that there was no difference in males and females' systolic blood pressure. Our final conclusion is that there is strong evidence to conclude that females have significantly higher systolic blood pressure than males in the sample from the Framingham heart study.